Well, if you were like me, I know that's a very scary thought. If you were like me, you might wonder, what is the square root of -1? I mean, what number times itself would equal -1? See, because it's a problem, because 1 times 1 equals 1, and -1 times -1 also equals 1. So what could multiply by itself to equal -1? Well, the answer is there's no real number that does it, but there's a number called I. I would call that imaginary numbers. Imaginary numbers, even though it seems like a very abstract kind of thing and very random and very just fairy tale useless, imaginary numbers are actually extremely useful in engineering and in calculus. There are many unsolved problems that were solved using imaginary numbers. Actually, we talk about complex numbers. What do I mean by that? If I have a number 2i plus 3i equals 5i. Well, the 5 is a real number. I is the imaginary part. By the way, if you notice, when we add imaginaries, it's like adding, like terms. 2 ice cubes plus 3 ice cubes is 5 ice cubes. What if I have just plain 2 plus 3i? What's that going to equal? Well, that's uncombinable. They're not like terms. So that's just going to equal 2 plus 3i. Now I can multiply. Let's look at multiplying. 2i times I just equals -1. Now if you have 2i times 3i, you multiply the 2 and the 3, you multiply the I and the I, but this simplifies to 6 times -1, which just simplifies to -6. Now 3 times 5i, well, there's only one I here, so I'm only going to multiply the 3 and the 5, and I'm going to get 15 positive 15i. Suppose I want to multiply 1 plus I times 3 plus 2i. Well, I'm basically going to FOIL it out. If I FOIL it out, I get 3 plus 2i plus 3i plus 2i squared. But I squared is just -1. Now, when I combine like terms, this reduces to 1 plus 5i. I equals I squared is -1, I to the third is I to the fourth is 1, I to the fifth is going to be I to the sixth will be -1, I to the seventh equals I to the eighth equals 1. Notice that this keeps on repeating every 4. So if I would give you a problem like I to the 37th, you don't need to multiply it out 37 times. Just divide it by 4 and see the remainder. So I to the 37th will be the same, is going to be equal to I to the 1, which equals I. And where did that 1 come from? The exponent came from the remainder. So over here, if I would give you I to the 74th power, well, if I divide that by 4, I'm going to get 32 remainder 2. I don't care about the quotient. I don't care about the quotient. I just care about the remainder. So I to the 74 is going to equal I to the 2, which is I squared, which is -1. Why do I always divide the exponent by 4? Because this is a cycle that repeats every 4 times.